For the third naming functional groups video, we're going to be looking at derivatives of carboxylic acid. Because each of these molecules is a carboxylic acid derivative, they will have carbonyl groups. The first molecule we're going to look at is an acid anhydride. Whenever a dehydration reaction occurs between two carboxylic acids, like in this drawing, the resulting compound is called an acid anhydride. If the R groups are the same on each side, and therefore the resulting compound is symmetrical, the acid name is followed by anhydride in IUPAC nomenclature. If the two groups are different, then both acid names precede the word anhydride. Remember, you count the carbonyl carbon as number 1. So this is an ethyl group, and this is a propyl group. Therefore, this will be ethanoic, propanoic anhydride. The next molecule we're going to look at is called an ester. These are molecules that have an OR group in place of the OH group of the carboxylic acid, where R is any organic compound. When naming an ester, the name of the R group goes first, that is attached where the H would have been attached to the OH. Then the name of the acid, where the ic acid of oic acid is replaced by ate. So if we look at this molecule, we see there's an ethyl here, that'll go first, ethyl. We see that this is a butanoic acid, so it will be ethyl butanoate. The next molecule we're going to look at is an aldehyde. An aldehyde is a carbonyl attached to an R group or an alkyl substituent on one side and a hydrogen on the other. Aldehydes are named by removing the E from the parent carbon's name and adding Al or al. So as with other hydrocarbons with a carbonyl group, the carbonyl carbon is number 1. So we number this way. 1, 2, 3, 4, 5, 6. There are 6. So it is a hexane, but we're going to change the E to al, so it will be hexanol. Our last molecule is a ketone. A ketone is a molecule where you have a carbonyl attached to R groups on either side of it. These are named by removing the E from the parent hydrocarbon's name and adding one, O-N-E. Again, we start with the carbonyl carbon. So if we number from this side, we have 1, 2, 3, 4 carbons starting at the carbonyl, or here we have 1, 2, 3, 4 carbons starting at the carbonyl. As always in a tie, we're going to number in such a way that we have the greatest number of substituents. So numbering in this direction, that makes this a 3-carbon group coming off the carbonyl. So we have 1 propyl, 3 methyl butone.